In today's video, we're going to be talking about implicit functions. So we're differentiating, or we're learning differentiation still, but this time we're going into implicit function. You would understand what that is in a bit. So we have 4 different questions. I hope we're going to be able to do everything. We will be able to do everything, but I hope we understand as soon as we're done. Okay, so what happens is we need to differentiate with respect to x. That's the first 3 questions, and the fourth question is a bit different, but it's the same principle that we'd follow. So let's start with number 1. So differentiate with respect to x, simply saying find dy dx. Okay, so with respect to x, so the first question is x squared plus y squared equal to 5. Okay, so now you would note that there's difference between this and your normal derivative question. Now normally you would have y equals to, let's say, something like 4x squared, and this would give you 8x, and that would be your answer, like when you differentiate. All right, but now we have y here. So how exactly are we going to differentiate it? So it's simple. We're going to differentiate x normally, then y, wherever we see y, we're going to differentiate that just a bit differently. So let's do that. So we differentiate with x, we have 2x. Now if we differentiate y, we would have 2y. But we can't leave it like this because we are differentiating with respect to x. So what we're going to do is we're going to put dy dx here. Okay, so because this is not x, but we have to differentiate it, we just add dy dx there. Now if we differentiate 5, we have 0. So now what we're going to do is, since we're looking for dy dx, we make dy dx the subject of formula. So we can take 2x to the other side. So we're going to have 2y dy dx equals to negative 2x. Okay, now dy dx again is what we're looking for. So if we divide both sides by 2y, we have dy dx equals to negative 2x over 2y. That would give us negative x over y. And it's as simple as that. That's how we solve questions like this. All right, so let's go over to the number 2. Let's go over to the second question. So for our next question, we have x squared y squared plus 2x plus 4y plus 6xy equals to 0. Now the difference between this question and this one is that here y squared, or y, was on its own. The term y was on its own. But now we have y coupled with x. So how exactly are we going to do that? Well, it's simple. Now we're going to differentiate this twice. We're going to differentiate this, we're going to differentiate x, and we're going to differentiate y. So now if we differentiate this term with respect to just x, we're going to have 2x. Then write your y squared like that. Just write y squared. All right. Then you have your plus. Okay. Now if we differentiate this time we're differentiating x. So therefore this would be x squared multiplied by 2y. Okay. If we differentiate y squared, we have 2y. But then we can now change this and write 2 here. So instead of writing x squared then 2y, we can write 2x squared y. All right. So that's how we solve this particular one. But remember, since it was with respect to x, we're going to write dy dx. Okay, I hope that makes sense. So now let's go over to the next one. So we have plus 3x. So now we're going to differentiate this normally. So this is going to be 3. Then we're differentiating 4y. So that will be 4, but with dy dx. Now we're going to differentiate this. So with respect to x, so you can look at it as just 6x. So that's going to be 6. But don't forget your y. Okay, now we're not adding any dy dx because we were differentiating with respect to just x. Okay, so now we have 6xy. So now we're differentiating y. Now if you differentiate y, that's going to be 1. So we're just going to have 6x. Now don't forget your dy dx. Every time you differentiate with respect to y, make sure you add your dy dx. Don't forget. Then obviously the derivative of 0 is 0. So what we're going to do is we're going to collect all the like terms together. That's all the bits that have, all the terms that have dy dx. We just keep them together. Then the ones that don't, we take them to the other side. So we have 2x squared y dy dx plus 4 dy dx plus 6x dy dx. So let's take anyone that doesn't have dy dx to the other side. So that will be negative 2x y squared negative 3 negative 6y, and yeah, that's about everything. So now we can factor out dy dx. Okay, so we're going to have just 2x squared y, because everything here has dy dx, so we can just take that out, plus 6x, then we can have dy dx over here. Okay, so that will be equal to negative 2x, basically everything that's up here, minus 3 minus 6y. So now we can remember dy dx is what we're looking for, that's the goal. So we can divide both sides by this term over here, by this term over here. Okay, sorry, by that term over here. So if we do that, so we have this. Okay, so we divide that, so it would cancel out. We've divided both sides, so this is out. So we have dy dx is equal to negative 2x squared minus 3 minus 6y all over, you can take out the bracket if you want to, all over 2x squared plus 4 plus 6x, and that's your answer. You can also factorize this by, you know, bringing out the minus sign, then obviously everything else will change to plus, but you can also leave it like that depending. All right, so this is our answer, and this is how you solve questions like this. All right, so I want you to pause the video and try to attempt number 3. Try to solve number 3 by yourself and see. It's the same thing. All right, it's the same thing, only that on the other side of the equality we don't have 0, we have like actual things that you can find the derivative of, but it's still the same process. So pause it, try and attempt it, and see if you understand it yourself. So we have the next question, number 3. So this is x cubed plus y cubed equals to 3xy. So it's the same thing that we're going to do. Okay, so now let's start to differentiate this. So if we differentiate x, we have 3x squared. If we differentiate y, we have 3y squared, but don't forget your dy dx. Okay, now this is equal to, now because this has x and y, we're differentiating it twice. So we differentiate, pretend like the y is not there. So if we differentiate 3x, we have 3. Now you can add the y back, 3y. All right, you are not adding any dy dx because we're differentiating with respect to x alone. So we put a plus sign. Now let's do the same thing for y. Pretend like x is not there, so we're differentiating just y, just 3y rather. So if we differentiate 3y, we have 3. So now pretend like the x is there, so that's 3x. Okay, so we have dy dx. Okay, so now what we want to do, remember we're looking for dy dx, so let's bring dy, all the terms that have dy dx, to one side, so it's easier to factorize it out and then find dy dx. So we're going to have 3y squared dy dx minus 3x, that's this, we're taking it over here, 3x dy dx equal to 3y, okay, take minus 3x squared to the other side, so that's minus 3x squared. Okay, so now you bring out dy dx, so we have 3y squared minus 3x, everything multiplied by dy dx. Okay, then you have this as well, 3y minus 3x squared. So now we divide both sides by what we have here, so we can have dy dx on its own. So dy dx therefore is going to be equal to 3y minus 3x squared over 3y squared minus 3x. All right, and that's how you solve this particular question. It's as simple as that, and that's your answer. All right, so let's go over to the final question, number 4, and we would be done with this video. Okay, so let's go over to the last question. So it says find the equation of the tangent where x is equal to 2 on the curve x squared plus y squared minus 2x plus y equals to 6. Okay, so now the equation of the tangent, obviously tangent is a line, so we can use the formula for the equation of a line, which is y minus y1 equals to m, which is our gradient, open bracket, x minus x1. Okay, so from here we see we already have our x. X has been given to us, but we do not have our y. So we need our y. Okay, so now let's get that. So what we're going to do is we're going to plug in x, our value for x, which is 2. So we can replace this x with. Okay, let's leave it like that first. So we're going to plug in the value of x, which is 2, into this. Okay, and then we get the value of y. So 2, we've plugged 2 into this, that will be 4 plus y squared minus 2 times 2, that's 4 plus y equals to 6. So 4, that's 4 minus 4, they'd cancel out. So we have y squared plus y, take this to the other side, minus 6 equal to 0. So now this is a quadratic equation. If you solve this, you're going to get that's equal to 0. If you solve this, you're going to get y plus 3 y minus 2 equal to 0. Okay, so now obviously our y here is going to be equal to negative 3, and our y here is going to be equal to 2. We just take 3 to the other side and take negative to the other side of the equality sign. So now we have the value of y. Actually, we have 2 values of y. So now we can replace this x, or we actually have, and actually write the values. So we have 2 comma negative 3 for 1, and 2 comma 2 for another. So now you see that we've gotten the value of x. So now let's see, we have the value of y, we have the value of x, but we don't have the value of m. That's what we're going to solve. Now the value of m would be the derivative of this curve. So if we find the derivative of this, then we find the value of m. Okay, so the value of m, that will be dy dx. So let's solve this. Let's differentiate this. So this will be 2x plus 2y, but because it's y, we add our dy dx. Okay, then for this we differentiate this normally, that's minus 2. Then derivative of y would be 1. So instead of writing 1 dy dx, you're just going to write dy dx equal to derivative of 6 would be 0. Okay, so we can bring the like terms, that would be 2y dy dx plus dy dx. Then we take all the other values to the other side, so that would be 2, alright, then minus 2x. So now let's open up, or let's factorize this. So that would be 2y plus 1 dy dx equals to 2 minus 2x. Okay, so our dy dx, this is just what we've been solving before. This is just to get the gradient, would be 2 minus 2x over 2y plus 1. Okay. Okay, so we have 2 minus 2x over 2y plus 1. So this is the value for our gradient. So now we have this. So now let's just plug in. Let's take 2 comma minus 3. So we can say at 2 comma minus 3. So let's find the gradient. We just plug this into that. So this would be 2 minus 2x would be 4 over 2 times minus 3 would be minus 6. Minus 6 plus 1. So 2 minus 4 would be minus 2. That would be minus 2 over minus 5, which would be 2 over 5. So that's our answer. Alright, but now remember, the equation of a line is y minus y1 equal to m x minus x1. Okay, so we have y. Our y1 here is negative 3. So that will be plus 3, because negative will be plus. And our m is 2 over 5. Then x minus x1. What's the value? So we have x, then our x1 is 2. Okay, so now let's write this properly. So we're going to multiply through by 5. So let's just take this part out. So we're going to multiply through by 5. So if we do that, we have 5y plus 15. And the reason we're multiplying through by 5 is to cancel out this fraction. So 5 multiplied by 2 over 5 would simply be 2, because 5 would cancel out 5. So this would be, we just have 2 here. So that would be 2x minus 4. So now let's take everything to this side. So it's an actual equation. So that will be 5y minus 2x. If you take plus 4 to the other side, that will be 15 plus 4. That will be 19. So 5y minus 2x plus 19 equals to 0. And this is the first equation of the tangent. So first equation of the tangent. So now let's go over to the second one because we have two values, remember. So let's go over to the second one. So if we find the gradient to this, now we're using at 2, 2. So that would be 2 minus 2 times 2 is 4. 2 times 2 here is 4, so that's 4 plus 1. So 2 minus 4 would be negative 2. 4 plus 1 is 5. So now we have negative 2 over 5. So let's plug that in. Remember the equation of a line, y minus y1 equal to m, open bracket, x minus x1. Okay, so our y would be here, minus y1. Our y1 now is 2. Our m is negative 2 over 5. Then what's our x? We have x. Then our x1 is 2 as well. So again, we're going to multiply through by 5. So we take out the fraction. So that will be 5y minus 10 equal to, now we just have minus 2 here because 5 would multiply this. So we have negative 2 here. So that will be negative 2 multiplied by x. That will be negative 2x. Negative 2 multiplied by negative 2. That will be plus 4. Okay. So let's just bring everything over to this side. So that will be 5y plus 2x minus 14. Because plus 4 will come here. It will change to negative. Negative 10 minus 4 would be minus 14. And that will be equal to 0. So our answer for this is 5y plus 2x minus 14 equals to 0. And those are the two equations of the tangent. Alright, so that's how we solve questions like this. I hope you understood everything. Again, if you don't understand anything, please leave a comment down below and I will try my possible best to answer that.